All right, so for this problem, we're giving the velocity here and our initial position there. So this first thing is asking us what's the acceleration of the object at t equals 4. So for this, we know that acceleration is the derivative of velocity. So I'm going to say v prime of t equals a of t, and I'm just plugging that into my calculator straight in, and that will be negative 0.524, or if you truncated it rather than rounded, you could have said, this is 4. So, and if you truncated, you could have also said, or negative 0.523, like that. So remember to do that. You're doing math 8, and then you're just saying, you don't have to write this obviously on the test, but like d dx equals, or sorry, not equals, d dx parentheses, we have sine of pi over 3 times x, so times x there, 2 parentheses, and then this bar evaluated at x in this case, x equals 4. But all you have to write is this, v prime of t equals a of t equals that. You do need to write v prime. I would write the a as well, but just at least v prime of t equals negative 5.24, or negative 0.524. So moving on for the next one. This next one, consider the two statements. Statement 1, for 3 less than t less than 4.5, the velocity of the object is decreasing. And statement 2, for 3 less than t less than 4.5, the speed of the object is increasing. So we know that velocity, it's just if the velocity of the object is decreasing, what that means, and I'm going to annotate this, is that here, v of t is not v of t, a of t, because the acceleration is going to determine how the velocity change. So a of t is less than 0. So that's the first one. Now, our second one is we have this. So the speed of the object is increasing, which means v of t and a of t. So v of t and a of t, so velocity and acceleration have same signs. So either they're both positive or they're both negative. So they have same signs. All right. Are either or both of these statements correct? For each statement, provide a reason why it's correct or not correct. So statement 1, what I'm going to do is I'm going to graph it, and remember you can just go to the y1 and you can do your math 8. So you can do math 8 for derivative d dx. Then what we're going to do is we're going to put that expression for velocity, which is that sine of pi over 3 times x. And we're doing it, so it's going to be that, again, that evaluated bar. So evaluated at x equals x. And we're going to graph that. So when we look at statement 1, so when we throw that in the calculator and graph it, we see that our acceleration means the derivative of velocity is is negative for the whole time, which means acceleration is always less than 0. So for this, the velocity of the object is decreasing. We say that this is true, and our reason is because v prime of t, and you don't have to say equal to a of t, but you're always welcome to say the derivative velocity, which is equal to the acceleration, so a of t, is less than 0. So that's why we know that's true. Now, our second statement. So if we go to our second statement, so we have statement 2. It's asking us about speed. So we already know that acceleration is negative. So statement 2. So we already know acceleration is negative. So then the next thing that we have to do is we just have to graph our velocity and see if that is also negative. So we're just plugging that straight in the calculator. And when we do that, we see that v of t is less than 0. So we say that here, true, that's a very ugly true, but true because v of t is less than 0, and we've already said a of t is equal to v prime of t, but you would either have to say v prime of t or a of t is less than 0. And what you can also say is velocity and acceleration have the same sign. I'm not going to write that out, but blah, 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 blah. Velocity and acceleration have the same sign. Can be your other reason. Alright, so moving on to the next one. So our total distance traveled is going to be the antiderivative, so the integral from 0 to 4 of the absolute value of velocity here, dt. And because this is the calculator section, you don't have to figure out when it's negative or anything like that. You're just plugging that directly into your calculator just like that. Because remember, so it's like the math 9, 0 to 9, and then if you go to math and you hit the right arrow, so you have num highlighted, so number, and 1. So math, hit the right math, hit the right arrow once, and then hit 1 to get those absolute value signs, and then you're putting the equation. And when you do that, so it'll take the calculator a little bit to compute it, but you'll get 5.72 or 730 if you round. So 5.730, and that, or if you truncate, you would get 5.729. So both of those would be correct. Now, last question, position at time equals 4. What we're going to do here is we take our position at t equals 0, so x of 0 plus the antiderivative from 0 to 4 of v of t. So if I remember correctly, x of 0 is negative 2. Sorry if I didn't remember that correctly. Math 9, 0 to 4, sine pi divided by 3 times x dx, and you would get for this, make sure you have the plus in between your negative 2 and your integral, and you would get negative 0.568. So, 0.568. 6, 8.